Hi, class. Hi, class. Yet another day after Bill's loss that you're hearing from me, but we'll make the best of it. So we're going to be talking about chapter 11 this week, which is managing knowledge, and we'll do some AI. So let's keep going. We're going to look at the role of knowledge management in a system. We'll look at a couple of the AI models that the author gives to us while reading, but you should read the rest. We'll look at what types of systems we use for enterprise-wide knowledge dissemination, and we'll look at the different types of systems and how they provide value to our organization. Excuse me. So we're going to watch two videos today. The first is IBM Watson becoming a Jeopardy champion. This is a particular fond meaning to my family, as my wife in her job with Geodis was able to send IBM Watson to the Sterling Forest Research Center to play Jeopardy. And next we'll see where Watson is now with IBM's Watson X platform. There we go. You got me back in because I forgot to share sound. All right, here we go.
I remember that morning going to the lab and I was thinking, this is it. This is the last Jeopardy game.
This is Jeopardy, the IBM Challenge.
Here we go. Brad, if you're ready, make your first choice.
Let's take alternate meanings for 200, Alex.
Four-letter word for a vantage point or a belief. Brad.
What is a view?
Yes.
After the first clue of the game, which Brad won, I had just this horrible feeling at that moment that he was as good as everyone said he was, and he was just going to run the whole board on us.
Watson.
What is shoe?
You are right.
We actually took the lead. We were ahead of them, but then we started getting some questions wrong.
Watson.
What is leg?
No, I'm sorry, I can't accept that.
What is 1920s?
No.
What is chic?
No, sorry. Brad.
What is class?
Class, you got it. Watson.
What is Sauron?
Sauron is right, and that puts you into a tie for the lead with Brad.
The double Jeopardy round of the first game, I thought was phenomenal.
Watson went on a tear.
Watson.
Who is Franz Liszt?
You are right.
What is violin?
Good.
Who is the church lady?
Yes. Watson.
What is narcolepsy?
You are right, and with that, you move to $36,681.
The risk was Ken gets a daily double, bets big, gets it right. He's going to be well ahead. And then with that kind of lead going into Final Jeopardy, if he bets enough, he could end up winning the match.
Ken.
What's a committee?
We got to find that last daily double. We got to find that last daily double.
It was a crucial moment in the game. There was still a daily double on the board, and it was starting to become pretty clear that it was in the legal ease category. Let's go to legal ease for 1200.
Watson.
What is executor?
Right.
Same category, 1600.
Answer, daily double.
That was the moment when I knew it's over.
The category is 19th century novelists.
What Watson wants to do then is preserve the lead, not take a big risk, especially with Final Jeopardy, because just like for humans, Final Jeopardy is hard for Watson.
Now we come to Watson, who is Bram Stoker, and the wager. Hello, 17,973, and a two-day total of 77,147.
I would have thought that technology like this was years away, but it's here now. I have the bruised ego to prove it.
My past Jeopardy experiences have been great, but they weren't really weighty with this kind of technological, philosophical importance. I think we saw something important today.
Didn't really think very much about the implications until later and say, wow, wait a second, this is history.
Of course, this whole project is not ultimately about playing Jeopardy. It's about doing research and deep analytics and a natural language understanding This is about taking the technology and applying it to solve problems people really care about. We're just so excited about all the things we can do with this.
I had thought this is the end. We get there, we're done. And I'm realizing it's just the beginning.
And now seeing what Watson X is all about. So Watson, who in the past has been the focus point of our semester-long projects, you can keep it as a theme or look up other things that you may be able to write about artificial intelligence and different systems. But there's so much out there about Watson and now Watson X. I don't want to watch again. There we go.
Time now for our Wall Street Week Daily segment. The host of Wall Street Week, David Weston, joining us now, as he does every day at this time. And David, we're almost through the end of earnings season. And one thing we knew heading into this earnings season was every investor wanted to hear what these companies had to say about artificial intelligence.
And you were right. We heard a lot about it. And it is your favorite subject, of course, Romaine, is artificial intelligence.
Yeah.
There's a big announcement out of IBM today, actually.
Okay.
They're having their Think conference. They're in the middle of that right now. And to bring us up to date, not just on Watson, but on Watson X, we welcome now Rob Thomas. He's IBM Chief Commercial Officer. So, Rob, thank you for being with us coming out, I know, of the conference. So, Watson X, explain to us what it is and why it's going to make our lives better.
David, look, something's happening in AI. Everybody knows it. Every CEO I talk to says, we're excited, but we're unsure of what to do. We are really pleased to announce Watson X. It delivers what every company wants: trusted, scalable, adaptable, a system for building AI, working with what we call foundational models. This is going to have a huge impact for businesses.
So it's very different, as I understand it, from getting ChatGPT to write a poem like Emily Dickinson. This is quite different from that. Explain what a company would do with this Watson X, what it gets from IBM, and then, again, what it builds on top of what it gets from Watson X.
It is different because I don't think people want their customer support in the style of Shakespeare, as an example. We're focused on business use cases like customer service, IT automation, cybersecurity. And Watson X gives you a capability for building models, for training models, for using open source models. We also have WatsonX.data, a way to bring data in that is trusted and understandable. And then lastly, we have WatsonX.governance, which is about AI fairness. Think of this as a nutrition label for your AI to make sure that what you're putting into work in your business is safe, reliable, and trusted.
Rob, remain here. There's been, of course, a lot of talk not only about the promise of this technology, but at least right now, the cost, the relatively high cost for the end user and how they use this here. When do we start to see a level of scale and, more importantly, I guess, a level of adoption where maybe the cost becomes a little bit more manageable for the companies that do want to use these tools?
Well, with Watson X, we've actually absorbed the cost. If you go back to 2020, we invested a lot of money to build the initial foundational models, and so clients no longer have to use that expense. The magic in AI comes with models, customer data, that's their proprietary data, and then domain knowledge or industry knowledge. So we bring a model that's already trained to do something. Customer just has to bring their data so they can get value much quicker because we've already absorbed the expense up front.
How much discussion has been had about where that data is coming from? There's been a lot of concern that certain companies aren't just going to be using their own internally produced data, but they're going to go out there into the world, into cyberspace or wherever, to scrape that data that in a lot of cases belongs to someone else.
This is a really important principle for us. So we use data to train our models. That is IBM data. So it's our data. Customers bring their data to the platform. That is their data. That is their model. It cannot be used anywhere else, which is one reason that we're able to avoid this phenomenon known as hallucination, because we're training on very narrow use cases like how do you better support customers? How do you better run your IT system? So we avoid those risks, but it is a risk for every company, which is why you need a capability like WatsonX.governance, which ensures that you understand where the data came from, how it's being used, how it's making decisions. That is going to give CEOs the confidence to give foundation models and generative AI a try in their business.
So, Rob, as a customer, it sounds good that you've invested all this money, but you expect to make some money off of it. How do you get paid? How does IBM make this into a real business?
There's a couple different approaches. Watson X is a platform. Anybody can subscribe to the platform and start using it, so we'll earn money that way. We've also built a capability in IBM Consulting around a center of excellence for generative AI. So when clients start to work on this, they might need help with technology, with data. They might need to work through the change transformation of changing business processes in their organization. So we can monetize through software, the subscription to the platform, as well as consulting for clients that want a little extra assistance as they bring this into their company.
Rob, you wouldn't have gotten this far if you hadn't talked to a few prospective customers. Where are you on the rollout? When do you expect to actually see this in practice? What sort of appetite is there out there? Who are your first customers?
We've been working with clients since January of this year. Many are using it. The big announcement we made last week was SAP, where SAP said they're going to adopt Watson as their embedded AI platform, and they're shipping product right now with it. So this is happening at the moment, and we'll continue from here. I think clients are still trying to figure out what is the first use case that I use. You take what we did with Watson originally around machine learning, deep learning. We have clients like Bradesco who now automate 300,000 customer service calls a month at 95% accuracy. So machine learning was working. Foundational models is even better because you can get up and running faster. So this is happening right now.
Well, what about for the world of finance, Rob? Is there a use case there specifically for Watson X and what you guys have developed?
We've decided to go after what I would call horizontal domains: IT automation, cybersecurity, automating human resources, automating finance, because this applies to every industry. And what we found is vertical use cases tend to not be as scalable, so they can become very complex and long-running projects. So we focused on domains that are relevant to every industry. Every employee has companies. Every employee has a CFO and an office of finance. Most companies have a supply chain. So we're thinking about these horizontal solutions that we know apply to every business.
Rob, every powerful tool has the power to do great good, but also maybe some harm along the way, whether intentionally or otherwise. Are you anticipating in your business model the possible government regulation?
We are working closely with Washington to evaluate what is the best way to regulate this, because I think the last thing anybody wants is unexpected consequences. The key point is, in this platform, we have designed in governance. So if you are using Watson X, the odds of something happening that you don't expect, I would say, are incredibly low. But we will continue to work with authorities and governments around the world to say, what is the right way to regulate AI? How do we prevent unexpected things from happening? I think it's a very important topic for all of us.
Time now.
And there we have it. A look at where Watson had been with machine learning and deep learning to where it is now. So you can keep your group papers along the traditional lines of machine learning, cognitive computing, natural language processing, or you could go Watson X and see where it goes in those channels. So what we're talking about now is knowledge. So knowledge is where a lot of spend is going with organization these days, not only to manage how we get knowledge into a computer system, but how we disseminate it or get it out. I want to bring up my laser. So substantial part of our stock value is related to intangible assets of knowledge, brand's reputation, and its unique business processes. I talked earlier that company is made up of its people and its processes, and we see that again. But realize, whatever IBM's trading at today, it's part of that is what's inside Rob, the presenter's head. That tacit knowledge, which we have a hard time, deciphering and disseminating, whereas we have explicit knowledge, things that are on paper, we have a much easier time in disseminating. So we talked about data as raw facts. Information is raw facts that have been processed. Knowledge is the next level in the data management tree, followed by wisdom. So wisdom is information with knowledge applied to it, and so on. We talked about tacit and explicit knowledge. I want to get through. There's nothing else that you remember from this chapter. Knowledge is situational. What's in my head for IT work is much different than what's in my head for anticipating St. John's versus Stony Brook tomorrow. Totally different knowledge bases. It has a location. It's either in our heads with tacit, or in some form we're able to see, touch, or whatever, and explicit. It has different forms. It could be an email, could be a piece of paper, could be a blueprint, could be a CAD drawing. And lastly, as we see in the other slide, knowledge is an asset of our firm. Sorry. Knowing how to do things effectively and efficiently in ways that can't duplicate is a prime source of profit and competitive advantage. So that's the bullet I want to take from this slide. And that goes back to our business processes. So we all have a unique way of getting from A to B, from X to Y and Z. And that process is special to us. Think back to the trade secrets we talked about. They have a space here. An example is Watson X, which we just seen. So knowledge management is the process of storing both tacit and explicit knowledge in a place where we can easily disseminate it. It has its own value chain that encompasses how we acquire that knowledge, what's the source, how we give it out, and what processes do we use to get it out there to our people. So knowledge acquisition piece, where do we keep this? Not in great places oftentimes. Our second square bullet, unstructured documents like email. Email is the worst place to file knowledge. You'd be better off with taking those documents or those attachments and putting them in OneDrive or SharePoint, somewhere multiple people can access, rather than the cumbersome world that our Outlook is. We can store documents, reports, presentations, and best practices easily through SharePoint and other portal applications. That created knowledge we can again disseminate rather easily. Like anything we've talked about, we store knowledge in databases, often in a document management system. So DMS is a practice of taking a physical document and digitizing it. It's an area that's slowly getting moved because of the quality of our cameras and the ease of taking a picture into a PDF. So things like Documentum are slowly but surely going away, while things like Adobe Scan are taking over, and we're now able to break that middle layer of our organization where we would need operational workers to scan things for us, and we would need to manage that. Now we can really manage ourselves. How do we give out knowledge? Let me get my pen, because I like the pen. We're not using wikis to disseminate. We do so through a portal of some sort. It could be self-contained and self-editable documents, but more often than not, it's something that's stored for reference. We've already talked about how we use email. We don't instant message. We can text, but more importantly, we would embed this in something like Teams or SharePoint. SharePoint is simply a collaboration tool. I often ask, is there too much information available out there? I used to give it as a final exam question in my Tech for the 21st Century class. It's not the fact that we have too much information out there or too much data. It's that we're not getting it in the right hands well enough. So how do we apply knowledge? Well, our author talks about 3 key pieces here, all of which we've seen were tasks that why we put information systems in place to begin with. Knowledge begets wisdom, could lead to a new business process, which could lead us to be more operationally excellent, which could give us competitive advantage to be able to get into new markets or new products and services. That's simply all our management value chain shows here. So our author then talks about kind of the hierarchy of knowledge management. In all my days working, I've never met a chief knowledge officer. I have met dedicated staff that handle knowledge, however. We used to have document retention and document management managers who reported to the CIO. Hopefully one day I'll meet a chief knowledge officer, just haven't come about yet. We can also build what's called communities of practice. We see this a lot when we search online to fix any problems we have. So say we're having a problem with our car, we throw in symptoms on a browser and we get a list of possible fixes. Well, the mechanics on that fix are a community of practice, an informal social network of professionals who are all looking to disseminate knowledge. These COPs often have education, as a how-to video would be, maybe an online newsletter, but definitely sharing knowledge. And COPs should, because we're organizing knowledge in such a way that we can get it out of the COP, our learning curve and orientation for new employees should be minimized. Types of knowledge management systems. I'm going to start in the middle. Knowledge work systems are not enterprise level, they are departmentalized. So think of maybe some of us who run into Bloomberg terminals before or CAD terminals before. These are highly specified computers that hold a specific task. CAD, computer-aided design, may go to engineers and scientists, whereas financial managers may utilize the Bloomberg KWS. It's the most well-known finance knowledge management system out there. Otherwise, we can store this as a module in our implementation of supply chain and customer resource management, and even our e-commerce platform to be able to disseminate. Our last bullet, which I didn't highlight yet, we did enterprise-wide knowledge management systems, we did knowledge work systems. I didn't do intelligent techniques. So this is where AI is coming into play. Data mining is predictive analysis using patterns in data to predict results. Great tool for Watson X. We have expert systems here as well, but that should really go over here. Traditional lines of AI, machine learning, natural language processing, computer vision systems. Robotics, another AI platform, and genetic algorithms and intelligent agents. So we'll look a little bit about some of this. We're not going to look at either of these two. I'll let you read about that. Same thing goes with neural networks. I'm going to talk a little bit about this one, computer vision system, by doing this. I'm always one to look for the latest and greatest. And I was getting my wife's glasses fixed, and I seen the latest and greatest. With these Ray-Ban smart glasses, I thought this was a very interesting thing. while as I didn't want to share people's germs to try these on in the store, I was intrigued by them. They're a traditional Ray-Ban frame with cameras built in, with biometrics built in, with Bluetooth built in to be able to communicate. No, it's not that much different than a regular frame. But there we have our camera. This can take our picture. We have audio. We can play audio through the arm of the glasses where it goes to your bone and not your ear. We get a more natural sound with that. We have natural language processing with Hey Meta. This is in collaboration with Meta. We have biometrics for security. We have a built-in charging case and an app to manage all of this vision platform. So I thought this was something that I may look for in the future. Different sizes, different colors. It can take prescription. So I don't really know the security here. I don't know if I would feel comfortable with just looking at my temple and taking a picture of something. That seems kind of shady to me. But what do I know? This is technology. This is AI at its best, as we see this performer or actress here doing. So something new from good old Al to show you all. But back to our slides. So AI is a fundamental that we want to get a computer system that can be, I'm not going to say smart as humans, but can give information as a human. We're not even close to this, even though we're seeing robotics played out a lot more. We're seeing systems like Watson and Watson X and the great things that Next Gen is doing. We all see some great incline on our curve of AI, but it's still not there yet. We still have to realize that this, like any information system, still requires human intervention. Although Watson and the Watson X platform does learn from its inputs and can certainly predict and, in a way, emulate what we would do. The types of AI expert systems: machine learning, neural and deep learning networks, genetic algorithms, natural language processing, computer vision, robotics. We heard generative AI. That's the latest and greatest coined phrase in AI. You all will probably get hands-on AI when things like Bing AI or ChatGPT. Those are like entry-level entrants using natural language processing and deep learning to be able to give us some kind of result. So our expert systems capture what's in our head and are able to get it out to somewhere else, often including processes for automation, like granting credit for a loan or diagnosing when machine's bad or cleaning up a mess at Stop and Shop. For highly structured decision-making, usually at the top of our hierarchy. Expert systems are logic-based. And if we run through this slide, I can show you how. This diagram shows us how we may automate a bank or other financial institution given credit. So what we see here, if A is, this is A to B, steps A to B, our first steps in this process. Well, if our income is greater than $50,000, our system should ask the next question. If we make $49,999, we're out the door, we're exited, and we can't get a credit line. So if we pass the first criteria, the next step's B to C. We ask if our car payment is less than 10% of our income. And I would sure hope it is. So if we're yes here, we move on to ask you about our mortgage. If we're no, we say thank you, goodbye. So if our mortgage is less than 20% of our income, we grant a credit line. If it's more than that, we exit the program. With the next condition met, our expert system then asks, how long have you been employed? If we're equal to or greater than 4 years, we're going to get you a $10,000 credit line. Otherwise, we're going to go down and ask, do we have any other debt? If that debt is less than 5% of our income, we're going to grant that same $10,000, or we're going to grant $3,000. So we have three possible outcomes here: a denial or two different credit lines based on a set of rules, or what we call business processes. Machine learning is used by the types of systems that we're not going to look at. It looks for patterns in large data sets, kind of like an analytics type of thing. But a great example of this is how Watson was learning the Jeopardy game and how it was able to take its inputs and its rules of the game to kind of predict where that daily double was going to be and what to bet in that final Jeopardy to be able to win the game. An example we see of this would be Netflix or Amazon's recommendation system in our accounts. There's two types of learning that this model of AI uses: supervised, where we train the system with human inputs and outputs predefined. And we see one technique is autonomous vehicles. A group in my Tech for 21st Century class did a great presentation on autonomous vehicles. It was really next level. And what they're doing with cars is amazing. And the decisions it's making from different inputs, sensor networks, optics is simply amazing. And unsupervised learning, where machines can make a decision, but we don't necessarily need humans involved. Natural language processing, I know we've all seen when we call for Siri, or we call for Cortana, or we call for anyone and their mother. It's using our voice to have some kind of hub make a decision for us. Kind of just looked at one use of computer vision systems. Another two are Facebook's Deep Face, which it really doesn't use anymore. It would use, I guess it does. It uses facial features to be able to recognize people you may want to tag. And again, autonomous vehicles, where the optics in the vehicle can see signs, road markers, people, animals. We're even so good that we have a computer touch system that can recognize patterns in our road, whether they're wet, they're icy, they're snowy, they're potholy, they're pristine. Robotics, I know we all are familiar with, to the ways of moving mostly, routine things that humans don't want to do, or it could be such great detail that humans really can't do it. We let these things do it. It could be a surgical robot opening up my left leg and putting my new knee in 2020. Or it could be those robots we've seen picking at Amazon last week. All a thing that we don't want to do, really automated. So, if I were to give us a lecture question, it would be this: will automation steal our jobs? And then I'd have you answer these three bullets. But I've noticed a few of us are just answering these interactive sessions, so I don't know if you're really watching these or not. So we're going to test that knowledge in that your assignment for our lecture is just to write in Pearson that I did not give you a lecture question. So I'll know if any of us answer this interactive session. I know they didn't really watch, so it's a little game for me. So no, just type in the assignment, no lecture question. Intelligent agents are a predictive analysis type of AI where we use known data sets to be able to do things like find the cheapest airplanes, airfare, deleting junk email. Even the focused and organized email in our Outlook is done by intelligent agents. We know chatbots are like ChatGPT. Like I said, the other types of AI you can read on your own. So now we're looking at what types of systems are used for enterprise-wide knowledge management. So we're being told there's 3 types of knowledge that we need. Our tacit knowledge are things that are unstructured, semi-structured like emails and videos, or things that are fully documented like reports or rules. Realizing though, 80 to 90% of our enterprise knowledge is stored in emails or in our heads. Two very unsafe places to store data. So what should an enterprise content management system do for us? It should be able to take inputs from the explicit knowledge, also have a way to capture what's in our head. We should be able to use different services to have data come in, as the slide says, news feeds. We have a means to decipher and disseminate this knowledge, blogs, wikis, a SharePoint site. You'll start seeing when we do internships and your first jobs, especially in bigger companies, we're going to have a database of employees. I know my wife's company, Geodis, has one, and one of the partners, IBM, definitely has one. It's called Blue Pages. But what do these do? Why do we need this? It goes back to our presentation that our group did with our Chapter 6 data. It's where we were finding what people, well, our customers, what types of events they would go to, and we'll see it again later in the semester. Well, we use these tools to find us an expert that can help us do whatever task we're doing. It's so refined these days that we can add social business tools to being able to help us do this, and actually promoting those people that are experts in our organization to the greater public. Learning management systems are what you're watching this video on. Zoom is, in a way, a learning management system, as is Brightspace, as is and was iLearn or Moodle, or any of the other open source training backgrounds there are on the internet, or MOOCs. What do? Well, we organize our participants, we organize what we are learning, we organize how we deliver that, how we make sure people are doing the learning, and a means to test our learning. We're going to go into a type of learning management system we use here at Greystone. This system is called Arctic Wolf. I use it for security awareness training, i.e. a learning management system. And I learn it for phishing simulation, another learning management system. Now I'm using Duo to log into this application, a multi-factor authentication partner. So what this tool is the back end to seeing what training I'm sending to people, how many have completed it, so we're not doing too well, how our dissemination of knowledge is equating to a quick score, 92% is not bad. Our phishing simulation results, 45%. It's better than the 75% we had last month. But this red is an opportunity for us to train. So we give them more training, and 60% of this 45 have actually, taken the steps to fix themselves. This is all organized by employee. I'll bring up my account, and we can see things I was assigned that I've completed. I can also assign myself a session. I think the only ones available to me are, I do have one, you have a new fax. And what happens, this will get disseminated to me in my email, which I can show you here. Cyber is one of those MOOCs I've talked about it just a minute ago. And I've yet to get that email. So I'll give it a second or two. I'll wait till I ding and I can go back to that. But that's a learning management system. Knowledge workers sit at the middle of our hierarchy, and they use these expert systems that we talked about. They're typically engineers, medical professionals, financial analysts, things like that, things that need these knowledge work systems to operate. These systems, again, are highly specialized, very powerful, have top-end graphics cards, great high-resolution 4K or greater monitors, having power to do multiple complex calculations and be able to pull data from many sources. They have to be able to communicate with our document management systems. They should be linked to external databases. Without them, no external databases are there. The best systems we can give our KWS workers have embedded feeds from external databases. They should be user-friendly. Why? These people make a heck of a lot of money, and what in their heads is very important. So we don't want to spend a lot of time training. We want to spend a lot of time working. And I talked a few of these already. CAD is a knowledge work system. Virtual reality and augmented reality systems are a type of KWS, the Bloomberg system of KWS, and so on. And that's it for this week. And I still haven't got that training email, so I would love to have been able to show you, but if the email delayed, I really can't. So again, remember to answer the question, and I look forward to chapter 12. Have a good one, everyone.